All right.
Yeah. Hi, I'm Kyle, and this is our chemistry application media project over colligative properties. Y'all can go ahead and introduce yourselves too.
I'm Anika.
And,
I'm Brazos.
and I'm Jason. Jason.
Okay, so the goal of the colligative properties lab is to relate the concentration of solute in a solution to the colligative properties of the solution, identify the freezing point of solution from temperature versus time data, and calculate the molar mass of a dissolved compound using the freezing point depression observed from the experiment. Okay, so for the general principle of colligative properties, they are physical properties that depend only on the concentration of solute in the solution and not on the type of solute particles. And as for the specific colligative property of freezing point depression, when a solute is added to a solvent, the freezing point of the solvent decreases because the solute particles disrupt the formation of the solid structure.
To determine the molar mass of the solute using freezing point depression, you first measure the freezing point depression. When a known mass of the solute is dissolved into a solvent, freezing point depression occurs because of the presence of the solute, particularly lowly of the solvent's freezing point. To find the molar mass, you would use the freezing point and the delta T equation, and then to find the equation of molality, you would do moles divided by solvent. And then lastly, to find the molar mass, you would do the moles of the solute divided by the moles of the solute. The experiment consisted of 4 sets of data: an 11 drum vial with 15 milliliters of deionized water for the freezing point at which it was placed in an ice bath containing table salt. After we took the DI water freezing point, we added an unknown substance to the vial and froze it. This unknown substance dissolved in water 3 times. We recorded the temperature when the water hit a constant and stayed around 0 degrees Celsius each time before taking the temperature of each. We weighed the empty vial, the vial with water, and the water with the unknown substance. This allowed us to determine the weight of the water added, and the steps were essential for later determining the molar mass.
All right, so for our data and results, we created two uh, scatter plots as we have here, and one is going to be for the temperature of the pure solvent over time, and one is for the temperature of the solution over time. And if we look at the plots, we can see that the change in temperature of the pure solvent had a lot slower of a rate than the temperature of the solution, as well as the uh, temperature difference. The solution was able to get to much colder temperatures than the pure solvent being water.
That's created a table for our results. So here is our table based on the results of our following experiment. And we are able to come up with the average molar mass, which is 343.7 grams per mole. And based on the average molar mass, we're able to identify the solute as sucrose, which is the closest one to it. It wasn't exactly 342.3 grams per mole, but it was the closest to that. So we're able to come up with sucrose. All right. Thank you guys so much. You guys have a great day.